Next, we will take a look at polymorphism. Polymorphism means many forms, or something that can take many forms. For example, a person taking multiple forms by behaving differently in different environments, such as how you behave at work versus home. And in object-oriented programming, one of the common references is it usually refers to child classes that are inheriting code from a parent class or parent classes, are able to override those methods and attributes by giving them a different set of rules to follow than the parent classes themselves. So these methods and attributes in the parent class and the child class can have the same names but have different rules to follow. And inheritance with polymorphism helps minimize repetitive code, it organizes code better, and it makes it easier to debug code. Now, how polymorphism can be achieved? So let's take a look at the common types or examples of polymorphism and how they can be achieved. So the first way, and the most common way in particular, with class inheritance, this is used in class inheritance, is method overriding. I have showed this in a previous video, but basically we can override a method inherited by a child class from the parent class with a different set of rules. So this is method overriding. Now let's take a look at the method overriding code in PyCharm. Now in Python, when working with classes, we can override code that is in the parent class by recreating it again in the child class with a different set of parameters. Let's start off by overriding a simple variable. And the first thing we will do is create a class called car with a variable name equals BMW. Now I will create a child class called myCar and specify car as the parent class of this child class. And let's not create any code in this class for now. Now let's create an object instance called newCar, which will be associated with the child class myCar. Now let's print our object new_car and associate it to the parent class variable name of BMW. So new_car.name, and we should get the name back of BMW. Let's run the file. And it's thrown up an error because BMW needs some quotes around it. Let me put some quotes around BMW. And let's run the file again. So we see BMW. So this means our new_car object instance, which is associated with the child class myCar here, is inheriting from car because it's picked up the car name. New_car.name, and it outputs BMW. So it's picking up the variable name BMW from the parent class car. However, in the child class, we can override this. So if we create a new variable name equals, let's call this one Audi, and run the file again. And now, although it's inheriting the name equals BMW, we have overridden it with the name equals Audi. So this is overriding the attribute or the variable. Let's do one specific to a method. Let's create a class called allCars, and I want to define a method to print this car has a spare tyre, as let's imagine all the cars our company sells come with a spare tyre. Let's call the method spare_tyre, and my print statement will say this car includes a spare tyre. Now let's create two classes, one class for Audi and another class for BMW, and let's make them both child classes of all cars. Next we will create an object called car_1, which will be created part of the child class Audi, and car_2 will be part of the child class BMW. Now if we print car_1.spareTyre, we see it picks up the method from the parent class allCars. Now if we copy the method and paste it in again as part of the child class Audi, and let's say although all cars come with a spare tyre, the vendor Audi is not offering cars with a spare tyre, so we want to override the parent method with this method. So let's change it to print. This Audi does not include a spare tyre. Now if we run the file again, we can see the method in the child class has overridden the method in the parent class. And this is known as method override. So now we can see print, this Audi does not include a spare tyre. And just to make sure it does not impact the BMW, let's print car_2.spareTyre. And we can see it does not impact car_2, so it shows this car includes a spare tyre. So it shows it's still inheriting the method from all cars. The next type of polymorphism is method overloading. And although the method overloading is supported in other programming languages like C++ and Java, it's not supported in Python. But just to cover it off and what it is, you can create the same method and it can exist multiple times in the same class. So you will see the same method name that will be present multiple times within a given class. And of course, different parameters will be used. However, with Python, No matter how many methods you create with the same name, it's always the last method that takes effect. So it's only the one method and it's the last method that will take effect. Now, with all that being said, there is an indirect way of using method overloading in Python to make some methods work, but I'm not going to cover it here. It's beyond the scope of this topic. But just so you know, there is an indirect way of making this work, and it basically sets default values to none and uses conditional statements to achieve method overloading in an indirect manner. And by the way, the differences between method overriding and method overloading is that overloading occurs within the same class, whilst overriding occurs in different classes. And the third way I'm going to cover off to achieve polymorphism is using operator overloading. So operators are able to behave differently according to the objects and the data types that are calling the operators. For example, operators behave differently if the data type was a string versus a numeric value, and Python translates the operator to which context it thinks you are using it in. So the meaning of the operator changes depending on how it's being used. So this is operator overloading. Let's take a look at some examples. Here is a very simple example of polymorphism with using operators, and the first examples are generic to Python, not specific to classes, but after this I'll also cover operator overloading with classes. When using the operators with strings, they behave differently when using them with numeric values. For example, 2 plus 5 equals 7, but if 2 and 5 were strings, it would print 25. So with strings, it concatenates them together. Or how about 30 being the integer times the string 5, and if we run the file, then we get the number 5 printed 30 times. Or let's print 10 times Audi, and we get the string Audi being printed 10 times. So this is polymorphism with operators in general, context to Python. Let's have a look at operator overloading in context to classes and objects. Now with classes and objects, Python doesn't know how to add two objects together. So let's create a couple of classes. Let's create car_1 and then we will initialize it and give it a price variable. And let's create the variable, the attribute for price. Now let's create car_2 and we will do the same thing as car_1. Now let's create two objects, C1 and C2. C1 will belong to car_1 and C2 will belong to car_2. And we will fill out the arguments, so let's give each of these a price. Car C1 will be 5,000 and car C2 will be 4,000. Now let's imagine someone wanted to purchase both of these cars. How would we add the objects together? If we do print and then do C1 plus C2 and let's run the file. So we get an error, unsupported operand types for the plus operator, car_1 and car_2. And this is because Python does not know how to add two objects together. It does work, however, if we added the specific attributes like .price at the end of C1 and C2, but how do we get Python to work it out using only their object names? So now we get 9,000, but again, if we remove these, we want Python to work it out using only their object names. So let's remove these again. So currently the plus operator does not understand what these two objects are and how to add them together. And to understand how to do this, we have to understand what's going on behind the scenes. So we need to add some code to be able to let Python know how to add the two objects together. And let's start off by understanding the built-in magic or dunder methods in Python. So if we temporarily open up a new file, file new, Python file, call it second file. Now when we do a equals 1 and b equals 1, and then we print a plus b, and then if we run the file, we get the result, we get 2. And this is because the plus operator in the back end of Python is actually using something called the magic method. It's a double underscore add and then it's followed by another double underscore. These are special methods that start and end with a double underscore. And these methods are invoked internally from the class depending on the feature we want to use in Python. For example, the plus operator in this case, it invokes the method double underscore add double underscore. And built-in classes in Python define a number of magic methods, and we can see how many magic methods are inherited by a class using the dir function. For example, we can see all of the things defined in a float class by printing dir and float in parentheses. So if we run the file, we can see lots of dunder methods, and actually the second one we see is the add dunder method. And of course there's lots of these supported. And we can even do something like this to show the add method in action directly. If we do something like a equals 50, we can print. So we can do a and then the dunder method of add, and then in brackets 2. So this is saying a, which is 50, add 2. And then if we run the file, we see 52. So that's how the operators work. And this is not only for add, it can be for subtract or any of the other dunder methods. And there's many dunder methods. So if we do underscore underscore, we can see all of them over here. So there's lots of them. But they are also on the Python website. So I've got a screenshot of them. So going back to the PowerPoint slide, and we can see they are on python.org. But if you go to this page, data model, you can see lots of these dunder methods. On the bottom right, we can see x is less greater than y and what calls it. We can see x dot and then the dunder method, le, which stands for less than or equal to, and then y, or x equals y. So that calls for x dot equals and then y. So you know which dunder methods to use and what they do. So this is again on the Python website, python.org, and the page in particular is called data model. So now that we have a bit of background information and we know the add method is used in the background, well, we need to overload this method. And we found out what overloading means. It means creating the same method again multiple times. So we have the built-in method, and in this case it's the addition method we want to overload. But of course you can do this for the other operators as well. So now if we go back to first py file, we can create a method underneath here to overload the plus operator. So let's define a new method. And we can see it has self and other inside here. So let's double click it. And just to make it clear, I like to specify other as other underscore object. So we define a new method with the double underscore add double underscore method, as this is the method we want to overload. And in here we get self and other, which will represent our two instances. So now what we need to do is we need to return self.price, and then it's plus other.price or other underscore object.price in our case, as we changed it. And by doing this, Python now knows when adding two objects, we would be adding their associated price variables. Because if we read it, it says self.price. So the first object instance .price, and then this is the second object instance .price. So if we now run the file, and we can see it's added them together. If we just scroll down a little bit so we can see the code as well as the output, we can see C1 plus C2, it doesn't have the variable price tagged at the end of each object, and it's still able to add both objects together. So we have now overloaded the operator with the functionality we need. And now there are two versions of it. The add dunder method that is built in, and the one that we just created to be able to add the prices of the two objects together. And this is known as operator overloading. By the way, we can also create methods for the other operators as well. Just do underscore underscore and we can see all of the dunder methods inside here. And that's it for this video. Thank you for watching. That's a high level overview of polymorphism in Python.